Welcome to another video by Mr. Jimenez, Learning Geometry with Mr. Jimenez. So today we're going to be talking about similarity and similar figures. Awesome. So what are similar figures? Well, here's the definition. This is an important symbol here because that is the notation we're going to. There is a difference between similarity and congruence, okay? So in similarity, we talk about two shapes are similar if the pairs of corresponding sides are proportional. And what does the word proportional mean? So proportional just compares ratios, right? And ratios are just fractions. So for example, 10 over 2, that is the same thing as 5 over 1. So these two ratios, right? This is a ratio and this is a ratio. And this whole thing represents a proportion, okay? So we're going to be exploring this idea, okay? So this is what a proportion is. Okay, so we know that the corresponding sides have to be proportional. So that means some fractions are involved there. And we also know that the corresponding angles have to be equal or congruent. All right, well, we know that already. So then, what is a similarity transformation? Well, we know what transformations are. We know what similarity means now. So what is a similarity transformation? Well, this means that two shapes are similar if we can map one shape to another using a dilation alone or a dilation in combination with another rigid motion. So let's give some examples here. So examples of similarity transformations are, we have a dilation because it clearly states here that it's a dilation alone. It can be a dilation alone. But now it also says that it could be a dilation in combination with a rigid motion. So we have a dilation plus a rotation. We have a dilation and a reflection. And how about you come up with one more? So let's use this notation now that we spoke about here, okay? So we'll say that two triangles, so for example, these two triangles, we'll call triangle, the first one, triangle ABC is similar to triangle, what are the corresponding sides here? Well, clearly A maps to D, so D, B maps to E, and C maps to F. So triangle ABC is similar to triangle DEF. Okay, so that means there are proportions here that we can make. Okay, there are definitely some proportions. What are the ratios that have to be equal? In any case, I'm asking you, how can I find the scale factor here if I don't know it? Let's first make an example. If AB is 2, and K, our scale factor is, call it 4, then what other side do you know? Well, I know that if AB is 2, then that means that I have to look at DE. And that means that segment DE is 2 times 4, which equals 8. So this segment here will be 8. This picture, the image, got 4 times larger than the pre-image. Now suppose that this side here, AC, is 3, and remember our scale factor is 4, then what other side do I know? Well, I know this one, right? I know DF. So DF would be 3 times 4, which is 12, okay? So that makes sense. That's 12. All right, well, that means that we should be able to set up a proportion. If these two triangles are similar, like we said, we should set up a proportion. And our proportion says that 3 over 2 should be exactly the same as 12 over 8, right? And is that true? Well, this one doesn't reduce anymore, but this one does, right? Let's reduce this fraction. Three over 2. This is equal to 3 over 2. So 3 over 2 equals 3 over 2. Done. Done. This is my proportion. Okay, how can this be helpful for us? Well, in any case, now I know, suppose that this piece is 1, right? I can actually set up a proportion to solve for this side if I didn't know my scale factor, right? I can actually set up a proportion. So I can set up the proportion of 1 over 2 is equal to, what would that be equal to, guys? Take a second. Try this one on your own. Okay. This is x, so this is x, right? These are corresponding sides. And 2 corresponds with what other side? 8. Oops. 8, right? And let's solve for this now. Cross multiplying, 1 times 8 is 8. 2 times x is 2x. So now I divide by 2, divide by 2. X equals 4. And that makes a lot of sense. This piece is 4 because the scale factor is 4. 1 times 4 is 4. Awesome. So the same exact thing would apply here, only that the center is weird because the center here is A. Notice that you extend the triangles from A. There are 2 triangles here, by the way. You have triangle ABC, and you also have triangle, the bigger one, ACE. So I recommend every time you see a picture like this, break it apart into 2 pictures like this, okay? Now you can clearly see the pre-image